13 students, welcome. We have a video here. It contains an example or two of finding and testing claims about two means, independent samples. This goes along with section 9.2 in our Triola text. Let me go ahead and share my screen. All right, so you should be able to see my PowerPoint here. Chapter 9, section 9.2, some examples here. Notation. Before I go over any examples, let me just discuss the notation. Mu sub 1, that's our first population mean. We don't know what that is. X sub 1 is our sample mean. We know what that is. Standard deviation from the first sample and sample size from the first sample. We have corresponding notation with little 2's instead of little 1's for our population number 2 and our sample number 2. There are requirements when we want to test claims about two population means. In this case, this population standard deviations need to be unknown, and they are. The samples must be independent in the sense that you've been looking at in the section. Selection into one sample has no effect on what happens regarding selection into the second sample. They have to be simple random samples. And then either or both of the following conditions must be satisfied. One or the other is fine, both is cool too. N needs to be greater than 30, or the populations need to follow a normal distribution. Here, we do not pool our data. Sometimes two populations have the same standard deviation. If it's likely that that is the case, we can pool our data. But a pretest is required, and we're not going to pool our data this semester. And I'll go over that when we get to our calculator. Technology. Our TI-84 has the ability to test claims about two means. We use the two-sample t-test with the p-value approach. I'll remind people that when p is less than or equal to alpha, we reject the null hypothesis. And when p is greater than alpha, we fail to reject the null hypothesis. Here's our example. We have a wind farm, and it must be placed in the most windy area available. We have a simple random sample of days in each region. There's going to be 2 of them here. The number of hours of acceptable wind speed on each day have been recorded, and we've recorded that for 37 days in region A and 43 days in region B. We have an average number of hours per day for each of the regions, as well as the standard deviation. The first thing we're going to do is test the claim that region A has fewer number of acceptable hours per day than region B. We're going to use an alpha level of significance of 0.05. Then we'll make a determination which of the two regions deserves the wind farm. Then we're going to construct the 99% confidence interval for the difference in mean hours between the two regions. So we want to test the claim that region A has fewer number of acceptable hours per day than region B. That's the question. Notationally, the null and the alternative hypothesis take this form. Mu sub A is equal to mu sub B. There's the equality we need for our null hypothesis. And mu sub A is less than mu sub B is the claim that the mean number of hours was fewer in region A than in region B. All right, so let me go ahead and pick up my calculator. There it is. Under stat, I'll go on over and I'll select the two-sample t-test. I have summary statistics, and I preloaded the calculator with the appropriate mean, standard deviation, and n for each of the samples. One thing I need to make sure is I select the correct tail of the test. This is a left tail test. And then we come to the pool question. Do we pool this semester? No, we don't. We're always going to answer no to that question. Select whatever pretty color you want. If you want to draw the picture, I'm going to go ahead and hit calculate, and I'll pick up the p-value. So I've got some weird degrees of freedom, and if you notice the formula in the section, it was quite bizarre. But what I'm really interested in is the test statistic and the p-value. Really, it's the p-value here, 0.0456 to 3 significant digits. So with that particular p-value, I can compare that to the level of significance of 0.05. It's less than the 0.05. We're going to reject the null hypothesis. The initial claim is supported at the 0.05 level of significance. So clearly region A has less acceptable hours per day than region B. So we're now in a position to answer the second question. Which region deserves the wind farm? Region B deserves the wind farm, as the mean number of hours per day is greater in B than in A. Remember, A is less than B, that means B is greater than A. So more hours in region B means that's where we're going to build our wind farm. Now, let's talk about the confidence interval. Your TI-84 has the ability to construct the confidence intervals for the difference between two means. And it follows the same requirements. We use the 2-samp t-interval tool to do this, and I'll run through those keystrokes also. So we want to construct a 99% confidence interval for the difference between the two means. Yeah, there is a point estimate. Here, it's the difference between the two sample means. 14.2 hours minus 15.6 hours means the point estimate for the difference between the two means is about a negative 1.4 hours. And remember, that's because the hours in region A were less than the hours in region B. All right, now we're ready to construct the confidence interval. So let me go ahead and bring back our calculator. I'll come over here and I'll scroll down to the area where the intervals are. We have a 2-sample t interval. And again, summary stats with the data preloaded. 0.99 is the confidence level there. We do not pool. Let's go ahead and calculate. Negative 3.56 and change to a 0.76 and change. I'm going to round that to 1 decimal place because my summary stats also have 1 decimal place. So when I come back to my presentation here, that confidence interval looks like a negative 3.6 hours less than mu sub A minus mu sub B, less than a 0.8 hours. So there we go. About the only other thing I can say is we really should check that we've satisfied all the requirements. The samples are simple random samples. We have a sample size of greater than 30 in both cases. The wind in one area doesn't cause the wind in any other area to blow a certain way. So it's the samples are independent. And clearly we had no idea of the population standard deviations in either case. So there we go. I'll go ahead and end that now, stop my share, and go ahead, try those keystrokes, make sure you can get to the same place I get, and we'll talk to you soon. Bye-bye.